Okay, given a function, we're going to be asked to find the vertical asymptote. And so this is going to be, we need to find the value that makes us, where we would get 0 in the denominator. It makes it undefined. So what you would take your denominator, set it not equal to 0, and solve. So just algebraically solving that, we could detect that x can not equal -1/2. It's defined everywhere except for that, so that means that there is a vertical asymptote at x equals -1/2. And this just describes where our function's undefined. And a lot of this is pre-cal, so we're not going to spend a lot of time on it. Our next function is x squared plus 2, x squared minus 4. Okay, so basically we take our denominator, set it not equal to 0. Okay, you can notice that that's difference of perfect squares and figure out that it's going to be 2 and -2, or you can solve this algebraically and get x squared. Move that over, and then what will we do? Take the square root of each side, right? But don't forget, when you take the square root of each side, you're going to get the positive and the negative, plus or minus 2. So you have vertical asymptotes at the line x equals 2 and x equals -2. Okay, these are real easy ones. So what value of x would make this undefined? 2. So right, you would take x minus 2 squared, set it not equal to 0, take the square root of both sides. So we would just be able to say vertical asymptote at what? X equals 2. The equation x equals 2. Okay, so you remember doing this. We did some work with this in college algebra and in pre-cal. Okay, so we'll have our denominator not equal to 0, so then that gives us x squared is not equal to -4, and then we take the square root of both sides. X is not equal to plus or minus. What happens over here? This is an imaginary number, just meaning so there's no vertical asymptotes here, because this would just give us an imaginary number, so there's no restrictions on it. So there's no vertical asymptote factors. If you have this, we would take our denominator, set it not equal to 0. What's this factor? What multiplies to give us a -20, but adds to give us a -1. What's that? X minus 5, x plus 4. Set each of those terms not equal to 0 and solve, so that would give me x minus 5 is not equal to 0. And x plus 4 is not equal to 0. So x cannot equal 5 and x cannot equal -4. So you have vertical asymptotes at x equals 5 and x equals -4. Like I said, I move really quickly through this. This is all review. Okay, if I'm very familiar with secant x, then I would be able to do that, but I'm a lot more comfortable with sine and cosine. So is there a particular way I could rewrite this trig function using in terms of sine or cosine? 1 over the cosine of x, right? Okay, so with that in mind, where the cosine is undefined is where the cosine of x cannot equal 0. Okay, where is the cosine of x equal to 0? Cosine of x is equal to 0 at pi halves, and what's the next place? 3 pi halves. Okay, now what if I kept going? That was for one rotation, so that was as, so you told me cosine of x is equal to 0 at pi halves, and then it was equal to 0 at 3 pi halves. What if I went around one more time? Then that would be 5 pi halves, 6 pi halves, 7 pi halves. So that would be at 5 pi halves and at 7 pi halves. And if I went around another revolution, it's all those places. So the cosine of x is equal to 0 at increments of, so we got pi halves, 3 pi halves, 5 pi halves, 7 pi halves. And what would give us that value is 2n plus 1 times pi halves. Okay, so if we're starting with the 0 term, this is when n equals 0. So what happens if n is 0? 2 times 0 is 0. 0 plus 1 is 1. What's 1 times pi halves? Pi halves. What about with n equals 1? 2 times 1 is 2. Plus 1 is 3. Times pi halves gives us 3 pi halves. N equals 2. N equals 3. So we could keep going around and around and around. So cosine is undefined. There's vertical asymptotes at all those values where cosine of x is equal to 0. And this would describe as many of them as possible, as many times as we want it to go around. That would be the formula that's going to describe that. Also, just to take a note of this, if you're asked to find the horizontal asymptote in your homework, you may have these particular functions and they say find the vertical asymptote, and we use these procedures, and it might say find the vertical asymptote, the horizontal asymptote. If you're asked to find the horizontal asymptote, you can use the procedures that we used previously as we took limits of functions as they approached infinity. So, or you can use the concepts that we did in pre-calculus that we covered previously. So if you want to look that back up, we took horizontal asymptotes of functions. So if f of x was given, we did that in pre-cal. So you can look at that to verify your answers.